everyone, and welcome to the 35th episode of MSME Masterclass. Today's topic is design considerations for steel structure and solar projects. And to address it, we have Mr. Animesh Manek, founder and managing director of Avishakti Rooftop Solar Private Limited. With over 18 years of extensive experience in engineering, procuring, installing, and maintaining rooftop PV solar power systems across India, Mr. Manek brings a wealth of knowledge to today's discussion. His expertise spans the entire life cycle of rooftop solar projects, from conceptualization to execution and ongoing operations. Mr. Manek is a seasoned industry practitioner and a dedicated learner. He completed a certification course on energy innovation and emerging technologies in renewable energy from the Stanford Center for Professional Development and holds a Master of Science in Engineering Management from the Florida Institute of Technology, which has equipped him with a robust foundation in managing complex technical projects. His commitment to continuous learning is reflected in his multiple certification and licenses from prestigious institutes, including the implementation of solar rooftop by entrepreneurs from USAID and standalone solar power systems design and installation from Global Sustainable Energy Solutions India. Moreover, he has completed the grid-connected rooftop solar PV power plant certification from IIT Bombay, underscoring his deep understanding of solar energy systems integration. Please join me in welcoming Mr. Animesh Manek to this webinar. Happy to have you, Animesh, today on our session.
Good evening. Thank you very much. I'm also happy to be here.
We look forward to an enlightening session with you. And with that, we will go on to our first question that we're going to ask you, which is to do with the key factors when it comes to designing steel structures for solar installations in India.
So there are several factors that are going to affect the design of the solar structures. And the most important critical one is the wind load. The wind load factor is very critical because that is the one factor which will affect it the most. Apart from that, the other critical factor is going to be the location of where the solar structure is going to be placed. So if I have to talk a little bit more about the wind load, what happens is that there is recently there have been a lot of cyclones that are coming through and passing through India, be it the East Coast or the West Coast. And these cyclones have created a very huge impact on the solar systems, especially the structures. So it has become very critical to ensure that the design that we are going to use for solar structures is very well tested and certified by a structural engineer. The other factor that I was talking about was the location and geography. The location and geography plays a very critical role from the perspective that if the structure is going to be closer to the coastline, then there's going to be certain, salt and mist factors that will affect the rusting elements of the structure. So we need to make sure that a higher level of galvanization is done to the solar structure to ensure that rusting is prevented for a period of 20-25 years. Apart from that, if the location is on a steep slope, then the design of the structure will be very different from a structure that is placed on a flat surface on the ground or on the flat surface of a rooftop. So these parameters are going to affect very heavily. Apart from these, the minor factors that will affect are what's the solar panel size, what is the orientation of the solar panel in which it is being placed, and budget and cost effectiveness of the solar structure.
Got it. And Animesh, how does the choice of steel grade impact the durability and cost effectiveness of solar structures?
So selecting the steel grade is going to play into the previous answer that I gave. Depending on the location and geography and the kind of strength required is going to be the most critical factor in deciding what kind of steel grade to be used. Most of the cases we are using steel grade that conforms to IS 2062. That helps us in our implementation, giving us the right balance of strength and cost effectiveness. So from that perspective, grade of steel is going to be affecting the durability and the reliability over the long term. So that's how it is.
Now, talking about the typical design loads, could you share some insights on what are the typical design loads that steel structures in solar projects must withstand in different regions across India?
So this is one particular aspect of the design of solar structure, which will very much remain the same throughout the country, apart from the wind load aspect. The solar structure has to withstand the dead load, which is going to be from the solar panels that are going to be placed on it. The other factor that will affect the design is the wind load again. So depending on the location and geography, different kinds of wind loads have to be considered. Apart from that, the other factor that needs to be considered is the temperature. Because different areas of the country have different temperatures, variability. So we need to make sure that this different factors are incorporated into the solar structure design, and it is able to handle the load of different parameters that need to be considered.
Understood. And Animesh, this is like a question that we've generally got when we talk about solar panels and steel structure supporting solar panels. In terms of the importance of corrosion protection in steel structures for solar installations, and what are your recommended methods?
Correct. So as we are all aware that the solar panels are having a lifetime of around 25 years. We have ourselves seen implementations which are more than 5 years old as of now. So what we have come to understand is that the biggest enemy of the solar structure is going to be corrosion. Because especially, we have seen it firsthand where we are in Mumbai. Because initially for our first project, we had ended up using a non-galvanized structure. And we saw that corrosion affected it very, very quickly. So we consulted with the customer and we got the whole thing replaced with a galvanized structure. And after that, it has sustained for more than 5 years now, and there has been no corrosion noticed on it. So as I was telling you earlier, that depending on the location, if it is closer to the coastline, then the corrosion factor becomes very, very critical. But when we are not so close to the coastline, the corrosion factor is not going to be so heavy. And the best way to prevent corrosion is to do a galvanization. Some of the vendors, some of the EPC players in the market are using pre-galvanized structures, but those pre-galvanized structures are not able to provide long-term reliability as the hot-dip galvanized structures are providing. So this is where we would like to highlight that hot-dip galvanized solar structures are definitely the way to go for preventing corrosion or, addressing the long-term reliability concern of a solar structure.
Perfect. And when it comes to design codes and standards, what role do they play in ensuring the safety and reliability of steel structures for solar installations?
Okay. So, when it comes to design codes, there are several design codes related to the wind parameters. Especially there is IS 875, which is the wind code. The section 3 of that is something that we consider as our Bhagavad Gita when it comes to designing the solar structures. When it comes to utilizing the grade of the steel, IS 2062 has proved to be very critical in making sure that the right steel grade is utilized. Making sure that when we are dealing with the structure manufacturers, we have to get involved at a very deep level and integrate with them when it comes to the fabrication of the structure, because we have to make sure that the right grade of material is utilized, and for that we sometimes even end up going to the factories to evaluate the material they are utilizing. So this is just an extension of the codes that are being utilized. Like, one side is that we just tell the fabricators that, or the manufacturers, that please utilize these codes. And the other side is that we actually go to the factory and ensure that those materials utilized are conforming to those codes. So this allows us to bring about a very standardized product across all of our projects. And it's something where these codes and standards help us to understand how the different materials will behave in different environments, and how they will get affected. So the design codes help us in making sure that we are doing the right kind of design for the structure, and the standards are the ones that help us in understanding what are the right materials that we should use, and how they will behave in different environments, and to make sure that we are giving the custom satisfying the custom requirement of the customer, instead of just giving a standardized product to all the customers, because depending on the different kind of customer, different requirements come up. So the standards and the codes are going to be the ones that we are going to be able to rely on for the solar structure.
Animesh, we've also heard that there are a lot of advantages of using prefabricated steel components when it comes to solar projects. So could you share what are the advantages, and if there are any specific challenges associated with its use in India?
Yes, there are a lot of advantages of using prefabricated steel components. The biggest advantages are that construction time required will be very fast. There is a lot of efficiency in the cost, from the cost perspective. There is a lot of efficiency from the time perspective. So there is a lot of uniformity in the output product also, because a single template is repeated again and again, so quality control becomes very easy. There is definitely so some of the challenges that we have come across in using prefabricated components is that it completely takes away any kind of flexibility and modularity or customization that we require at times. Certain projects like megawatt scale projects are definitely can take advantage of the prefabricated components, but when it comes to rooftop projects, there's a lot of challenges, because we need to have a lot of customization. Also, some of the other challenges that we have noticed are that there is not sufficient skilled labor available to be able to cater to the requirements of creating prefabricated components. At times, there are a lot of logistics and transportation related challenges, because sometimes the component size is such that you cannot have a certain size of vehicle available or something like that. So especially when it comes to the purlins, which are what is a very critical component of the solar structure. So the preference is to have the single piece purlin for a structure. And if we need to have a larger structure, like for a megawatt scale, then the purlin size becomes very large, and it becomes challenging to find the right logistics and transportation partner to make sure that the delivery happens and things like that. And sometimes there is certain parameters related to the manufacturing capacity also, because if the right kind of machinery and all that is not available, then the manufacturing capacity gets affected, and that affects the overall implementation of the solar structure. That way.
Got it. And how can MSMEs optimize the design of steel structures to minimize material use and construction costs? Now, this is all without compromising on the structural integrity.
So this is something of a challenge that we have been trying to understand from some time now. And what we have realized is that if we are able to utilize, different kinds of advanced software technologies that are available to use for the design, then there is definitely a possibility to reduce the, wastage and optimize the, efficiency of the design. There are definitely some kinds of standardization methodologies that can be, brought into utilization. Some kind of, size standardization, if it is brought into the picture, that across the country, this size is to be utilized for certain columns, or this size is to be utilized for certain rafters, this size is to be utilized for purlins, then definitely we can bring about a lot of optimization in the design side as well as the manufacturing side also. Also, it will help in the construction of the solar system when such things are happening. So definitely, and taking help of modular designs will also definitely help with optimizing, making sure that all sorts of pieces that are coming together, if they are coming together in a very modular fashion instead of they being welded in advance, then definitely there is a lot of optimization that can be done.
Okay, and sorry, I'm interrupting you. Go ahead.
No problem. Yeah, and there is sometimes there are ways that these manufacturers can cut on the base by trying to find ways to recycle and reuse the components and things like that. So definitely a collaborative approach between the EPCs and the manufacturers will help in making sure that all kinds of optimizations are done and waste and all that is minimized. All the while keeping in mind that a lot of structural integrity is not compromised.
Understood. And Animesh, what are the considerations for integrating tracking systems with solar steel structures or steel structures in solar farms, and how does that affect the design process?
So for designing the tracking systems, the most important parameter to understand is what kind of tracking is expected. Is it a single axis? Is it a dual axis? That it will determine the kind of design that needs to be done. Apart from that, the load that is to be handled by the structure is also something that needs to be handled in a different fashion than what a fixed axis structure will be. There are certain kinds of dynamic loads that come into picture because of the tracking machinery that comes into play, and these dynamic loads have to be considered while doing the design. Apart from that, there will be certain amounts of vibration and fatigue. So because the tracking mechanism is continuously in operation, it's a moving part. So there will be some kind of vibration happening all the time. And over the period of time, there will be fatigue. There will be, some kind of greasing that will be required. So there's a lot of maintenance parameters that need to be considered for the design of tracking-based systems. And we have to make sure that the stability of the structure is also, I feel, is a very critical component, and aligning and making sure that, because when it's moving and moving back into its place, then every time the alignment should stay so that the next time when it starts moving again, it's not off and doesn't affect the generation and things like that. And to make sure that we are able to achieve these things, we have to make sure that the right kind of material is selected, right kind of mechanisms are utilized. And, at the end of the day, after doing all these considerations, we have to make sure that a lot of cost benefit analysis is being done and made sure that the structure designed is having that optimum cost benefit analysis, so that it is palatable not only to the customer but also to the manufacturer.
Understood. And also, Animesh, how can MSMEs ensure the compliance with regards to local regulations and permitting requirements when it comes to designing steel structures for solar projects?
So the local regulations regarding the solar structures, that is one of the biggest challenges in our country. As of now, not every state has a very well-defined local regulation when it comes to solar structures. In Mumbai, before 2020, there was no particular regulation regarding how the solar structure needs to be, whether there will be permissions required for this kind of a structure or that kind of a structure. So it was a very confusing time for all of us EPC players. But fortunately, with the introduction of the recent DCPR document, it allowed us to have a visibility into how the state government is looking at the solar structures and what is it that bothers them and doesn't bother them. So they have a very clear guideline where it states that when you are doing an installation on top of a rooftop, then the height of the structure can only be a certain level, certain height on the front side and on the back side and things like that. So that allowed us to make sure that our design becomes very standardized from that perspective. So it is very important to just understand the local regulations to be able to comply with them. And whenever you are doing a project where you realize that local regulations will come into play, you need to make sure that you're planning in advance, that informing the customers in advance. Like just today I had a meeting with one of our customers who wanted a super elevated structure, and I had to inform them that if you're wanting a height of clearance of 9 feet, that is 3 feet above the 6 feet limit set by the local regulatory body, then in that case we need to ensure that there is the right permissions are in place, and only then we proceed with the rest of the project. So to ensure that we get the right permissions, it is very critical to hire the correct qualified professionals who will engage with the local bodies. Like there are architects, there are consultants who are doing these kind of processes on a daily basis. So it is important to engage with them, incorporate them into your project planning process, so that they can make the customer aware of all the different situations and scenarios that they can come across. Because non-compliance will directly lead to either the project will have to be destroyed at a later stage if the local regulatory body comes into picture, or there will be heavy fines involved to ensure that to regularize the structure. So making sure that the design compliance is done at the right stage and in the right fashion will ensure that all MSMEs will be able to benefit from this kind of compliance, and make sure that the customer also doesn't face any problems because of this. Apart from that, I feel that it is important to make sure that all the right process to get the permission is also followed. Like, if there is some kind of applications, if there is any kind of inspection that needs to be done from the local body, if there is any kind of training that needs to be given to the customer side, and all sorts of documentation that needs to be done should be done to ensure that the permissions that is required is acquired in the proper fashion. And once the permission is in place, then everything works out really well.
Brilliant. Now let's talk about trends, because that's a hot topic when it comes to any sector, any field. Could you share with our attendees what are the current trends when it comes to designing software and tools for optimizing structural design of steel components in solar installations?
So when it comes to solar installations, there are there are an array of softwares available. The primary ones that are utilized these days are three. One is known as SketchUp. SketchUp is utilized very heavily in the rooftop segment of the structural design, where it is very easy to create a 3D model of the structure that we are going to place. And this helps not only us, but also the customer to visualize how their structure will look once it is constructed, because it can be designed to scale. We don't have to minimize or maximize the structure or anything like that. Also, taking it a little further, once we are done with the 3D model in SketchUp, we can take it further and go into AutoCAD, where multiple views of the structure can be designed, giving the exact specification of each and every member and how those members will be distanced from each other. So AutoCAD gives a very strong edge when it comes to interfacing from the EPC vendor to the manufacturer, because when you have a clear AutoCAD drawing in place, then the fabricator or the manufacturer can give you the accurate results. And that is very critical, because when you're implementing those structures on the site, if the structures are not accurate, if there is errors in the structure, if the holes are not drilled in the right place, or if the members are not of the correct size, then the entire structure will be a failure. So that is a very critical tool that is available. And the third critical tool available is the STAAD.Pro software. The STAAD.Pro software is utilized by structural engineers and by EPC vendors as well, to ensure that the design that we have created is able to sustain the wind load. Because knowing, as we discussed earlier, that wind load is the most critical factor that is going to make sure that our structure is going to last, even if there is a high intensity cyclone that comes into the picture. So these are the three softwares that are very much in trend. Apart from this, there are a lot of other softwares out there, but we prefer to go with these three, and we have noticed that they are very in trend with all the other players as well in the market.
Lovely. So we've covered the trends. Now we move on to the challenges. Could you share with our attendees the typical challenges that are faced during the fabrication and erection of steel structures for solar projects in India, and how can we overcome them?
So as I was saying earlier, that making sure that the structure is designed correctly. So all the way from the 3D modeling of the structure to the AutoCAD drawings, it is a very challenging task, because we have to understand how the different members will come together and how they will be connected with each other. It is also very critical to understand that the connection points are created in the correct fashion, so that it can withstand all sorts of different loads that are required for us. So the most foremost challenge is the design and the design optimization, to make sure that the structure is going to be able to prove itself over the period of time. Apart from that, the corrosion is the biggest challenge that is going to be faced when it comes to not only fabrication but erection of the solar structures. So we have to make sure that we are having adequate amount of protection. So as I was talking about galvanization, there is a standard that was created by the central government when they introduced the subsidy program, which made sure that all the structures, solar structures utilized, are hot dip galvanized, and they are having minimum 80 to 120 micron of galvanization. So this was something which allowed some kind of standardization to come into the solar structures, and it helped prevent the corrosion factor that is affecting the fabrication and erection of solar structure. So apart from this, there is the transportation and logistics that we have talked about earlier. That is one of the challenges that is faced, getting the right kind of transportation, and making sure, because sometimes the transportation entities that are available, they are trying to, not use the right kind of vehicles, and they are trying to manage in smaller vehicles and things like that. This can definitely be a challenge, because if you are not able to receive the material on time, or if it gets damaged while it is being transported, or if it gets there are different types of damages possible. A structure could bend, a structure could the galvanization could get damaged, there could be mishandling during transportation. So these kind of challenges need to be addressed by making sure that you are choosing the right vendor. And for MSMEs, it is not that difficult to do, because if you are collaborating with the right manufacturer in a very integrated fashion, where it's not that you just place the order to the fabricator or the manufacturer and you're just raising your hands and you're just expecting the delivery. That is not going to help overcome these challenges. MSMEs have to get involved with the manufacturer. They have to integrate themselves into the process of the fabrication. That will allow the fabrication side of things to be handled. When it comes to the erection side of things, making sure that the right design was submitted to the manufacturer, and doing checks with the manufacturer that the right design was fabricated. Sometimes there are these kind of tests that are available, where they pre-assemble the structure at the manufacturer side to showcase that yes, the structure has been fabricated correctly. This kind of procedures, if they are followed, then erection side of the structure, it will also be very smooth. Making sure that you again visit the manufacturer once the structure is fabricated, to make sure that all sorts of challenges that you can imagine are overcome at that stage itself, so that it's not something that once you got the delivery, you realize that, oh, this structure is not correct. So that kind of these kind of simple basic actions taken by MSMEs can help very well overcome these challenges.
There are two kinds of structures that we will discuss, which is rooftop solar projects and ground-mounted installations. Now tell me, how does the design of these foundations vary when it comes to steel structures?
So when it comes to designing of foundations for different kinds of structures, we have to consider certain parameters. So for example, if I'm considering a rooftop solar project, then making sure that the load distribution that is required to support the solar panels and the structure is achieved properly through the foundation. Making sure that the right kind of support is provided to. So basically, the foundation is the connection point between the structure, solar structure, and the existing terrace or the roof. So, foundation becomes the pillar on which the load is getting distributed, support is being provided. And, especially when it comes to rooftop, we have to make sure that there is right kinds of waterproofing and insulation parameters being considered. Because when we are dealing with the roof, the first and foremost, concern from the customer side is that I should not have any kind of water leakage once you do the installation. So, that is the customer side's perspective, that they should not have any water leakage. So when we are doing the installation on the roof, we have to make sure that right kinds of, these adhesives that are available for binding the existing concrete to the new concrete are being utilized. So to do that kind of things, we ensure that the right product is used, the right size of the block is utilized, to make sure that all sorts of different perspectives of the design parameters are taken into consideration. When it comes to ground-mounted installations, the perspective changes completely. You need to make sure that the right kind of soil conditions are available. You need to understand how deep you need to dig to get the proper kind of support load to ensure the load bearing capacity is handled. What kind of foundation types? There are various types of foundation available. You need to make sure that this will be suitable for this kind of soil type. You have to consider the environmental impact also of your foundations because they are going to be going into the ground. So you don't want to impact the environmental factors of the soil and the area around and things like that. So these kind of parameters are at play when it comes to design of foundations for the solar structures.
Got it. Now, when we talk about effectively managing quality control and assurance, in according to you, how can MSMEs do that during the manufacturing and installation of steel structures for solar projects?
Very interesting question. So as we discussed some of the points earlier, making sure that proper, design is integration is there. Like, you're submitting the design to them and they're verifying the design and saying, yes, everything is fine. So in a way, you're establishing a sort of a quality standard for the design between you and the manufacturer. Apart from that, making sure that the right kind of materials are used as per the expectations set from your side to the manufacturer. Then making sure that you have the right suppliers and the reliable suppliers available to provide you with the right kind of quality of material over the period of time. Like for us, in our case, we have been getting our supply from one particular manufacturer for the last 5 years, and he has proven with the quality and the making sure that the design is very optimized. He has made sure that the structure is having right kinds of there has never been a case where the right size of the structure was not available. We have even had discussions about making sure that the wastage is at the minimum level, so our design is optimized from that perspective, and making sure that all MSMEs can do these kind of things. Like as I said, we can make sure that there is a regular inspection to make sure that the right product is being used. Some kind of documentation should be there. Like every time we receive our product from the manufacturer, we ask them to give us a knife test. We ask them to give us the galvanization test report that they have achieved after the galvanization. So these kind of documentation related to the structure quality will ensure that you will always get the good quality product that way.
Okay, now talking about cost implications, what are the potential cost implications of different design choices? Could be, modular or into orientation or structure configurations when it comes to these solar installations.
So when it comes to the cost implications, module orientation will impact very, very much, because when you're having modules placed in portrait orientation, you're able to have multiple panels with just the supporting purlins. When it comes to so when it comes to landscape orientation, the number of purlins required will increase, because as per the design methodology that is being followed, the purlins are always going to be going from east to west. So from that perspective, when we are placing the solar panels in portrait orientation, then we are utilizing less amount of the purlin area per panel. And when we are putting it in landscape orientation, we're utilizing much larger area of the purlin. So, module orientation will definitely affect the cost, because the more amount of material is required for the structure, the higher the cost will be. When it comes to the different kinds of structural configurations like height, roof location, things like that. So from that perspective, especially when it comes to height, it will make a huge difference again. So higher the height is, the stronger the structure needs to be to withstand the high speeds. The lower the height is, the structure can be lesser in strength because it can still withstand higher winds better at lower heights. So these kind of structural configurations will come into play when it comes to the cost, because immediately it's directly related. Again, material choice will also make a huge difference, because as we said, we found this right balance with the materials that are conforming to IS 2062. But if you're going for a different kind of material, the cost will vary. And just going for a cheaper material will be, upfront cost will go down, but the lifetime cost will be, it can be very high. It is something that is not being studied or researched upon very effectively, but definitely you are looking at very high operation and maintenance costs. You are looking at very high costs when it comes to facing corrosion and damages and things like that. So from these perspectives, different parameters will have direct cost implications. So it is very important to make sure that you find the right balance and you figure out the cost benefit analysis and make a decision after the cost benefit analysis.
Okay, now let's address a question that we received from our audience, which talks about how does the design of steel structures for solar projects differ from utility scale and decentralized off-grid installations in India?
So when it comes to utility scale projects, as we discussed earlier, there are certain parameters which are different from a rooftop or off-grid solar installation. So the structure design is, it can be very simple because there is large amounts of space available. There is no space constraint, and there is a very fixed kind of a template for the solar structure. So it becomes a little on the easier side. The foundation requirements is what becomes very critical from the structure design perspective. So to make sure that the right kind of foundations are there and the structure is supported correctly. And apart from that, we need to make sure that the integration with the grid is also being done properly. To ensure that because when it comes to utility scale projects, the most critical parameter is that your evacuation point is nearby. And to make sure that your evacuation point is nearby, the selection of the land will be directly affected. And based on the selection of the land, your structure will directly be affected, because the different parameters will come into play, like what kind of soil is there, what kind of wind impact is there on that location, and things like that. So these are the considerations that need to be done when we are doing utility scale structure design. When it comes to the off-grid solar installations, it is important to just focus on the prime parameters, like you want the structure to have a lot of customization. You want it to be very modular. You want to be able to make sure that if in future we want to add some additional capacity, then we should be able to do it easily. Also making sure that maintenance and durability is easier. So like maintenance perspective becomes very critical, because when it comes to rooftop or off-grid solar installations, you don't have the same levels of tools available or the skills available to be able to, which are available on utility scale side to do the maintenance. So you need to make sure that your structures are pretty much maintenance free and they are having long time durability. That's it.
Got it. And my last question to you, Animesh, for today's webinar is, what are the considerations for retrofitting existing steel structures to accommodate new solar installations or upgrades?
This is one of the parameters that nobody in the industry is considering. Is a very interesting question. What is happening is that we are at a point in the industry where the technology is developed. We have gone from 300 watt solar panels using polycrystalline technology all the way to 550, 600, 700 watt panels having the latest mono-PERC technology and N-type technology and things like that. So what has happened is the size of the solar panels has changed. And we have realized that this is something that we will have to keep in consideration going forward, because the size of the solar panel, the shape of it is going to keep changing to, as the technology advances. So retrofitting of the solar panels, retrofitting of steel structures will become a very critical aspect in the coming times because of this continuous improvement in technology. So from that perspective, what happens is that going back to the drawing board and making sure that our designs are done in a certain way that we have. So as of now, when we're designing rafters, we just have the necessary holes available to place the purlins where the solar panels require it. But if we have to make certain changes to it in such a way that we can add additional purlins, connect to it at a later stage, then it will be very easy to add more structures where newer solar panels will be able to place with the existing structures. So making sure that the existing structure is able to be compatible with the future design changes will definitely make a huge difference.
That was the last question to you, Animesh. Thank you so much for sharing your valuable insights and critical design considerations. Your expertise, I'm sure, has helped us through optimizing structural integrity, cost effectiveness, and regulatory compliance. So thank you once again, Animesh. It was lovely having you.
Very nice talking to you too. Yes.
If you'd like to watch any of our episodes or the current episode, please log on to our YouTube page, which is GSW1 MSME, and you can find all our masterclass episodes uploaded there, including the current one. So do not forget to subscribe. Thank you so much.
It's W1 MSME. Okay, that's the YouTube channel. All right.
Yeah.
Great. I'll look forward to it.
Thank you so much, Animesh. Bye-bye.
Very nice talking to you. Bye-bye.